Welcome to section 6.2, where we'll be solving systems of equations again, but this time using something called substitution. Here's our warm-up. The first one, I want you to cross out the expression that does not include a variable. The second one, I want you to circle the equation in which the variable is isolated. Let's see how you did. The expression that does not include a variable was this one right here, 23 plus 9. Remember, a variable is a letter. This has a letter, this has two letters, and this has two letters. Circle the equation in which the variable is isolated. Remember, isolated means all by itself. This one's not isolated. This one's not isolated. This has the letter all by itself. This one has an additional 4 there. Our vocabulary word for the day is substitution. In general, a substitution is something that takes the place of something else. We are going to focus more on this definition down here. We can solve linear systems by solving one of the equations for one of the variables. Then you substitute the expression for the variable into the other equation. This is called the substitution method. Now, we have some steps for solving systems using substitution. The first step is to solve the equation for one of the variables. Our second step is to substitute that value into our other equation. Our third step is to solve the equation. Our fourth step is to plug back in to find the other variable. And our last step is to check your solution. So what does this look like? Well, we're going to pick the easier equation when we're going to solve for the variable. The goal is to get y or x all by themselves. Substituting means we're going to put the equation in step 1 into the other equation. Solving the equation means getting the variable all by itself. Once you get that value in, you substitute it back for the variable into the equation, and finally the two answers that you get, you substitute both of them into the equations and make sure that it gives you a true statement. So here we have y equals 2x and 2x plus y equals 8. This is a system of equations. Now we'll notice that the first equation already has the letter y by itself, so therefore we don't have to do step 1 from our previous slide. We're going to take the 2x and we're going to put it in for y in the second equation. So now instead of the y, we have the 2x from our first equation. Combine your like terms to get 4x equals 8. Divide both sides by 4 to get x equals 2. Now that I know what x equals, I come back to my two original equations and I can use either one to solve for y. I've chosen to use y equals 2x, so I put the 2 for the x and I find that y is equal to 2. So my solution is 2, 4. Here we have another example. Again, I have two equations here, 8x plus 6y equals 30, and x equals 3y. Notice the second equation already has the x by itself, so we're going to put the 3y in for x into equation 1. So that's exactly what I've done. I've put the 3y in for the x, so I take 8 times 3y plus 6y equals 30. So that gives me 24y plus 6y equals 30. 30y equals 30, divide both sides by 30 to get y equals 1. Since I know what y equals, I use either equation and put the 1 in for the y to solve for the x. I've chosen to use the second equation. X equals 3 times the 1 for the y, so x is equal to 3. And then we check our solution. I've chosen the first equation this time, so I have 8 times 3 for x plus 6 times 1 for y, and see if that equals 30. 24 is 8 times 3, 6 times 1 is 6, so 24 and 6 gives me 30, and 30 equals 30, so it checks, so my solution is 3, 1. This time we have both equations that have the letter y by themselves. So again, we pick either one and we're going to set them equal to each other because we're going to take the 3x plus 1 and put it for this y, or the 5x plus 3 and put it for this y. So we now have this equation to solve. We need to get the letters on the left by subtracting 3x from both sides. We get 2x plus 3 equals 1. Subtract 3 from both sides to get 2x equals negative 2, and finally dividing both sides by 2 to get x equals a negative 1. Once we know what one of the variables is, we pick either equation to find the value for y. We chose to use the first equation, substituting in the negative 1 for x, so 5 times the negative 1 gives me negative 5 plus 3, so my y must equal 2. My solution is negative 1, negative 2. Another example, we want to solve the system y equals 3x plus 4 and y equals 6x plus 1. Notice they're both equal to 0, so you set both equations equal to each other. Subtract the 3x from both sides to get the letters by themselves. We have 4 equals 3x plus 1. Subtract the 1 from both sides to get 3 equals 3x. Divide both sides by 3 to get x equals 1. Once you know what one of the variables is, you substitute back into either equation. I've chosen to use the first equation. So I put the 1 in for the x, so I have 3 times 1, which is 3, plus 4 equals 7, so my y is equal to 7. Then we have to check. I used the second equation, and I decided to check to see if y equals 6x plus 1. When I put my y, my 7 in for y, my 1 in for x, 6 times 1 is 6 plus 1 is 7, so since it checks, it is my solution. Let's take a look at another example here. We need to solve the system using substitution, and we're going to check our answer. You try this one and see how you do. First, they want us to circle the equation that shows a substitution from one equation to the other. Again, noticing that they're both equal to y, we substitute the x minus 1 or the 2x plus 7 in for the y's and set them equal to each other. Once we do that, we need to get letters on one side, numbers on the other side. So subtract x from both sides to get x plus 7 equals a negative 1. Subtract 7 from both sides to get x equals a negative 8. Once we know one value, we go back to our original equations and substitute in the negative 8 for x. I chose to use the second equation, so y equals a negative 8 minus 1, y equals a negative 9. So the solution should be negative 8, negative 9. We check using either equation. Using the first equation, we get negative 9 equals 2 times a negative 8 plus 7. Negative 9 equals negative 16 plus 7. Negative 9 equals negative 9 is a true statement, so we know that we are correct. We could have also used the other equation. Negative 9 equals negative 8 minus 1. Negative 9 equals negative 9, so it checks. Your homework assignment is on page 371, numbers 11 through 16.